Picture this. You are walking up to your front door after a long, exhausting day at work, carrying heavy bags of groceries in both of your arms. It is pouring rain, the wind is freezing, and you suddenly realize your house keys are buried deep at the absolute bottom of your backpack. We have all been stuck digging for our keys while completely miserable and soaking wet on our own front porch. But what if your finger was the absolute only key you ever needed? For centuries, we have relied on small pieces of jagged metal to keep our homes, our valuables, and our families safe. But let us be honest, traditional mechanical keys are incredibly annoying. They get lost in the couch, they get stolen, you accidentally lock them inside the house, or you are forced to make physical copies for friends, neighbors, and dog sitters, constantly worrying about who actually has access to your front door. That is exactly why millions of homeowners are upgrading to smart fingerprint locks. You just press your thumb against a sleek glowing pad. The door instantly beeps and you are inside. But how does this magical glowing piece of glass actually know it is you? Is it really secure? Or could someone just use a printed picture of your fingerprint to break into your house while you sleep? Today, we are going to look behind that digital keypad, strip away the complicated computer science, and break down exactly how a smart fingerprint lock works step by step. We will discover what is actually happening inside the heavy metal hardware to keep your home completely safe, and why you can finally throw those old heavy metal keys into the trash for good. To understand how a fingerprint lock works, we first have to understand the brilliant, one-of-a-kind design of your own hands. If you look very closely at the tip of your index finger right now, you will see a complex, swirling maze of tiny raised lines curving around in circles and loops. These raised lines are called friction ridges, and the valleys between them create a geometric pattern that is completely unique to you. No two people in the entire world, not even identical twins, share the exact same fingerprint. Traditional mechanical locks use a series of physical metal pins hidden inside a cylinder. When you slide the correct jagged metal key inside, the precise cuts on the key physically push those pins up to the perfect height, allowing the locking mechanism to turn. A smart lock essentially does the exact same thing, but instead of using a jagged piece of metal to push physical pins, it uses an advanced digital scanner to read the unique ridges on your finger. When you press your finger against the scanner on your front door, the lock has to take a hyper-detailed reading of your living skin. Older or cheaper smart locks use something called an optical scanner. Think of this like a miniature digital camera and a bright LED flashlight hidden inside the lock. When you touch the glass, the flashlight shines onto your finger, and the camera snaps a high-contrast black and white photograph of your fingerprint. It looks for the dark lines where your skin touches the glass and the light areas where the valleys of your print do not touch. While this works fine for a smartphone, optical scanners can sometimes be fooled by a really good high-resolution printed photograph of a fingerprint, which is obviously not ideal for securing your house. That is exactly why almost all modern high-quality residential smart locks use a much more advanced piece of technology called a capacitive scanner. Instead of taking a visual photograph, a capacitive scanner uses a tiny grid of thousands of microscopic electrical sensors. Human skin naturally conducts a tiny, completely safe amount of electricity. When you press your finger against a capacitive scanner, only the raised ridges of your fingerprint actually physically touch the electrical sensors. The valleys of your fingerprint sit slightly above the scanner, leaving a microscopic pocket of air. Air does not conduct electricity the same way your moist living skin does. By measuring these incredibly tiny electrical differences across the grid, the lock's computer chip creates a highly precise, three-dimensional electrical map of your finger. This technology is absolutely brilliant because it requires the physical presence of a real electrically conductive human finger. If a thief tries to hold up a printed photograph or a fake silicone mold of your fingerprint, the scanner will instantly deny it because those materials simply do not have the right electrical properties. Once the capacitive scanner captures that perfect three-dimensional electrical map of your finger, it sends that data instantly to the lock's internal computer brain, which is a tiny microprocessor. Now, here is a fantastic security fact. Your lock does not actually save a picture of your fingerprint. Instead, it turns your fingerprint into a complex mathematical code known as a hash. This microprocessor compares the mathematical code of the finger currently touching the pad against the master template that you safely saved in the lock's memory when you first installed it. The computer is looking for specific microscopic anchor points, like where a ridge ends abruptly or where a line splits into two different directions. If enough of these microscopic data points match perfectly, the computer mathematically confirms your true identity in a fraction of a second. Now that the computer knows it is definitely you standing at the door, it has to physically open the heavy lock. This is where the digital world seamlessly meets the mechanical world. The microprocessor sends a quick electrical signal to a tiny high-torque electric motor hidden deep inside the heavy metal housing of the lock. This motor is connected directly to a series of mechanical gears. When the motor receives the approved signal, it quietly whirs to life, turning the gears, which physically pull the heavy steel deadbolt out of your wooden doorframe. You hear that satisfying mechanical click, the green light flashes, and the door is completely unlocked. The whole process, from the moment your skin touches the glass to the heavy steel bolt sliding back, happens in less than a single second. And because the entire system runs on standard alkaline batteries, it continues to work flawlessly even if your entire neighborhood loses electricity during a massive summer storm. Furthermore, most of these locks feature an auto-lock function. A small sensor detects when the door is physically closed against the frame, and after a few seconds the motor automatically spins in reverse, shooting the steel deadbolt back into the wall. You will never have to drive down the street wondering if you remembered to lock the front door again. Beyond just using your fingerprint, the true beauty of these smart locks lies in their wireless connectivity. Most modern locks connect directly to your home Wi-Fi network, allowing you to control that tiny internal motor from anywhere in the entire world using a secure app on your smartphone. You can instantly generate temporary digital passcodes for your house cleaner, check the activity log to see exactly what time the kids unlocked the door after school, or let a trusted friend inside to water your plants while you are thousands of miles away on a tropical vacation. You are in total, absolute control of your home's security, and you never have to hide a spare metal key under a fake rock on your front porch ever again. Understanding the brilliant technology guarding your front door brings serious peace of mind, making your daily life safer, smarter, and vastly more convenient. If this breakdown helped you finally understand smart home security, hit that subscribe button, give this video a quick thumbs up, and tell me in the comments below if you would ever trust a fingerprint lock for your own front door. Thanks so much for watching, and stay safe out there.